My first video in my first course. This course is Go How to Program. I will explain programming from zero. So you just need to know the basic things about computers, applications, programs, and code. Let's start and write our first Go program. Okay, let's run and execute this programs. It prints this hello to my first program. Okay, this is what our simple program do. Just prints this text to the screen. Okay, let's see to this program. This program have this function which is belongs to the FMT format library. We imported this format library here to use one of its functions, which is println. Function is a block of code that should make one job or one function. So we put it in function to call and use it many times. Okay. Any program, in fact, has two or three things. Program has, okay, one input, two processing, three output. Okay. For our programs, it has output. This is the output. There is no processing, but of course, inside this println, there is some processing, okay? And there is no input, of course, here. But in most cases, must be processing and output existed, and in also in most cases, the input is existed too. But what it should be is a processing and output in any real program. Without output, there is no benefit from the program, and also without processing. What the program is do? Programming is a processing. Okay. For example, let's extend our program. Let's say we want to print this. Okay, let's run it. Fine. This is the output of program. This is two statement output, and this is part of the output, but at the same time it's processing. So it multiply 2 by 5 and gets the result 10. Okay, we can do this like an input, for example, with variables. Let's say I equals 2, j equals 5, and then here we have j multiply I. It's the same, of course. Also we can say here I, and here j. This is the same also. Okay, this is I will be 2 at output. At output will be evaluated from I to its value, which is 2, and I will talk more about variables, and this j will be 5 as it's here, and then this is the result of multiplication. So this is input of the program, this is the processing, and this is the output. So every program, let's say, has input, processing, output. Whatever the program size was, from most simple program as ours to the big and large one, you must keep in mind the input of the program or the application or the software, whatever, and the processing you need to do, and for the output you need to get. So let's say output equals processing multiplication input, multiply by input. Okay, this is the output. So you need to keep in mind what's your input is, or what is, and what is processing. Why I made processing before? Because it's more important. Okay, input is easy to get and to realize, but the processing is the heart of the program. And with this, you get the desired output. Okay, let's think in large applications. For example, let's see, let's say, Instagram, for example. Instagram has a processing for users and their related images and their friends. Okay, this is processing to get what we see from result. The inputs are users and friends and images. Then it make relations between them for you to see what is important and what is related to you. So everything is about input, processing, and output. Okay, let's just return to our Go program. We have for every Go program we have package in every file. In general, the Go program contains many packages, and each package can have one or many files. So this is what makes the Go program. For example, this file, the main file, main.go, it can be this name main can be anything, but the package for the executed file, this file, we cannot make it executed if it was not main. So for example, if we added main and we said this, he will see, yeah, run after build is not possible. Main file has non-main package or doesn't contain main function. So either it doesn't have the main package, or it doesn't have the main function. So it must be main package to execute it, and must be this function the main, the same one. Okay, this is just to be executed, but you can of course write many files that will not be executed itself, because because they are just helpers, but the executed point, it's one point, and this will be in the function main. This what function main does. It's the entry point of the application. How the application or the operating system, when it talks to the application, how to know where's the entry point. This is the entry point of the application. You start your application, your program starts from here, main. So we can make another function. Let's say multiply and takes ij integer and return I multiply j. Okay. this function name is multiply, it's not main, so the program will not start from here. Okay, for example, if we said fmtb println hi, I am multiply function, and we made it run, this will not be executed because this is not the main function. The main function, the entry point of the program is this. Okay, now for example, if we want to use this multiply, we can say it here, multiply ij. It's the same I multiply j, but we have this ham function here. Okay, we want now this, of course, so we can comment it to not be outputted, but let's see something. When we call multiply, this is executed first. The output of this is the first output. This means that the println doesn't make anything output from here. It just gets and evaluated the all of its parameters, then it outputted it. This is clear from here. Okay, this output is called from here multiply output hi I am multiply function is the first output in the program. Even that I, this symbol, and j is before multiply, but println doesn't output anything before the other parameters, all parameters at the same time. So why this is why this outputted first I and j. This is I2. Okay, let's delete this and our program will be like the first. Okay, that's fine. Okay, fmt y, this is the library fmt format. We imported it to use the println function. Okay, if we didn't import it and try to execute it, okay, Goland and Go will import it itself. Goland. Okay, Goland. Thank you, Goland. Okay, so this is our first Go program. Any program has three things: input, processing, and output. The Golang program has package. Every Go program and Go files belongs to package, and we may need to use another libraries, so we import them by import statement, and then we have the entry point of the program, the function main, and then there is our program. And we need to use and write another function, so we can write them here on another file. Okay, now let's speak about variables. Okay, fine. This is what any program has. Now, also, any program do two things. Program does that. This is what program has. Now, this is what program does to store data. 3. Data processing. Okay, this what every program do and nothing else. Anything you can think in, from add to numbers, from view and watch a movie, any processing, chatting over internet, calls, make calls over internet, anything, any program do is store data and processing this data. Nothing else. Okay. To store data, we need something to store in. Of course, when the program is at running time, the data the program use are stored in the RAM memory, random access memory. Okay. The program languages help us for storing this data. So they give us variables. Variables are names that store data for us by simple names, but in fact they store them at the RAM memory, and at the RAM memory there are cells, we can say cells, and we can access these cells by their addresses, and their addresses are in hexadecimal form, and we cannot use the hexadecimal form easily. So instead of them, we have variables where their names are just any name you want in English language with numbers you want maybe. So for example, this I, we call it a variable, and its value is name. It's 2. Why it's variable? Because its value can be changed. Can be changed anytime. For example, let's say it's 10. Okay. What is this? Okay. Change it. Then I multiply j. What will be? 50. Because I is 10 is not 2 anymore. So when we change it, the previous value is removed and the new value is stored. So this is variable in its simple form. In fact, in Go, we can define variable in many forms. Let's say we have a variable var name is Go. Okay. We didn't use name, so it's a problem. Okay. Let's use it here. Fine. So this is the keyword var. Keyword means that this word is reserved by the language. We cannot use it like variable or any other thing. We can use it just for the users in the language, nothing else. For example, I cannot say var equals 6. But to say what is this var. Okay. For example, if say var1, it's okay. So this, what does it mean? Reserved word. It is reserved by the language, so we cannot use it only except the way the language forces us to use. Okay, this is mean that name is variable and this is its value. Because this value is inside these two quotations, then Go knows that it's a string, but we can say var name string. Okay, this is that mean it's string. If we say this var name, it's wrong. We didn't give it a value, so it can't know what the type of the value could be, the type of the variable. This means that in Go, every variable must have a type. Okay, the type can be integer, float, string, boolean, anything. Okay, but we can say string. Okay, now it's okay, there is no problem. Name is a string. Fine. Var x, let's say float 32. Okay, because we didn't use it, so it says that. Okay. Why do we use types? To know, not us just, but Golang also, to know what the value can be stored in the variable. So when we make a mistake and store a wrong value, Go knows that and give us a warn. This saves us away from the logical errors. For example, if you need to store an integer value and then find its multiplication with another number, but by mistake you store a string value, you cannot make a multiplication on a string. This is a problem, an error. Okay. And any language that enforce you to have a type for the variables, is called a strong typed language. So we have strong typed language, and we have weak typed language. Weak typed language, it's doesn't force us to define a type for the variable. So variables can be free from types. Many languages, particularly the dynamic languages, scripting languages like Python, PHP, JavaScript, of course. Okay, there is advantages and disadvantages for the two types, strong typed languages and weak typed languages. But in fact, for me, I prefer strong typing languages. It's better with a higher performance and with less errors. Okay. Okay. Let's now know the variable types in our Golang. There's x float 32 and 64. They store the floating number, but the difference in the size of memory. So of course 64 bit will store larger numbers with more precision. Okay. For the integer, we have integer 8, 1 byte, integer 60, integer 32, and 64. And of course, we can store in 64 large number, very larger than integer 8, for example. Also, we have byte, which is just an integer 8, the same, there's no different. Okay, it's just a name, alias. We have bool, which can store true or false. Okay, let's say this. It's the problem in this. Okay, it's not bit. If empty dot print x, x is true or false, of course will be true. Fine. This is because it's bool. We have run. Okay. It's one character, one Unicode character. In fact, we can give it of a value with run. Let's see. Okay. Really. Okay. I don't remember it. Type string to type, okay. Technically, I don't remember it now, but let's say it and print it. Okay, it saves it. It's number, yeah. The output will not be this. Let's say what is this? Okay. Fine. We will come back to run. Like later. Okay. We have also what we have. Integer, byte, float. We have complex. Fact. Complex 64 or okay, let's say none minus 2, maybe this can be okay. Undefined and print, yes. Okay, this is complex number. It's very good thing in Go to manage and process complex numbers in very easy way. This is good format. Okay, let's talk more about variables. As we said, variables has types. The type of variable, let's say this. Type of variable determines size of variable at the memory, at the RAM memory. So if it's, for example, 32, this means 32 over 32, 4 bytes, of course. So it needs 4 bytes at the memory to keep any variable. Its size is 32, and 8, of course, if it is 64. So type of variable determines first the size, 2, the range of values. Let's see this. Let's see x var x integer 8. Fine. Now x equals to 127 127 and print it. It's okay. If x is 1 to 8, 100, this says constant 128 overflows integer 8, because integer 8, which is integer with 8 bits, just 8 bits, 1 byte, size of 1 byte, cannot store value more than 127, cannot store 128. Why? We can know this from that 2 to the power 8, what is it, minus 1, what does it equal? Let's see, calculator. What is this? Oh, it doesn't useful for me. This is the first time I use this calculator. Okay, 2 to the power 8 is 2 multiply 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 2. Where is it? Come on. Really? Okay. Let's see. Let's use our Golang. 2 multiply. Tick, tick, tick. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is good. Print line. Okay, what is it? Didn't print it because of this error. Okay, it's 256. Okay, we need to divide it because the half of this is positive and the half is negative. So when we say 202 will give us 128. This is the maximum number in positive but with minus 1. Why minus 1? Because the 0 is in the positive numbers. It's part of from the positive numbers. So integer 8, which its size at memory is 8 bits, just 1 byte, can store at positive numbers until to 127 and can store in negative 100 until minus 1 and 128. Okay, so this is what we mean from that type of variable determines the range of values. This is the range of values of 8 integer 8, and of course for any other um, variable. For example, when say variable is boolean, this means that we can store only two values, the true and the false. When we doesn't initiate any variable with a value, for example, when we don't say this true, so Go gives them a default value. Okay, for boolean the default value is false. Okay, if it is not boolean integer, of course it's 0. If it is string, it's nothing, empty string. It's just like this. It's empty string. Okay, if it's a float, not there. It's 0.0. Okay, 0. There's another different. Fine. So this is the second thing we can take from the type of variable. The size. The first thing is the size, then the range of values. I remember there's a third one. Size, range, okay, yes. Operations on the variable. Okay, what this means, okay, when the variable is float 64 or any float number or even integer, this means that we can make arithmetic operation, addition, subtraction, multiplication and division. Why? Because it's a float or it's integer. If it is boolean, we can make not or and add, nothing else. Okay, so this is What does it mean when, according to the type, we have the operation on this type or variable with this type? So the type of variable determines these three things. We must keep this in our minds too. Fine. Let's end at this point and continue in the following videos. See you.